In this video, I'm going to do an introduction to square roots. But the main thing we're going to do is learn how to simplify radicals. The reason we have to learn how to simplify radicals and work with these square roots is because we use what we're going to learn right here to write the equation of a circle. And we're going to learn that just a bit in this module. Before we talk a whole lot about finding a square root and simplifying radicals, it's really important to know what a perfect square is first. Um, a perfect square, when you square something, let's just go through the, you know, integers 1 through 10. If I say 1 squared, that's the same thing as saying 1 times 1, and it's 1. 1 is a perfect square, okay? 2 squared is the same thing as saying 2 times 2, and 2 times 2 is 4, which makes 4 a perfect square. 3 squared is 3 times 3. And 3 times 3 is 9, so therefore 9 is a perfect square. 4 squared is 4 times 4, which is 16. Therefore 16 is a perfect square. And then 5 squared is 5 times 5, which is 25, which makes 25 a perfect square. Now, and I said I was going to go through 1 through 10, but I'm not. I'm done there. Okay, now that's a perfect square. That's when we square something. Let's talk about finding the squared root. Well, if I say the squared root of 1, this is what I'm trying to find. That's really the same thing as the square root of 1 squared, or the square root of 1 times 1. And that square root just so happens to be equal to just the number 1. Well, let's go to the number 2, or excuse me, right here, the square root of 4. We're taking square roots of perfect squares right now. The square root of 4 is the same thing as the square root. I could write as the square root of 4 is the same thing as 2 squared, right? So the square root of 2 squared is the same thing as the square root of 4. Or 4 is also equal to 2 times 2. The square root of 4 is 2. Okay? The square root of 9. 9 can be written as 3 squared, or 3 times 3. So that makes the square root of 9 just 3. Okay, that 3 repeated. Okay, the square root of 25 is, well, you could say that it's 5 squared, or 5 times 5. That makes the square root of 25 just the number 5. So the easy thing about finding the square root of 1 and 4 and 9 and 25, it's easy because they're perfect squares. I can even type the square root of 1 in the calculator and get 1. I can type the square root of 9 in the calculator and get 3, and that's simple because they're perfect squares. Well, let's talk about what to do to find the square root of something that is not a perfect square. The square root of 8. 8 is not a perfect square. I can't type. If I type the square root of 8 in the calculator, I don't get a pretty whole number. I get a decimal. I get 2 point something. Okay. So in order to simplify this down to get something exact, I take the number 8 and I start dividing it by prime numbers. Okay, a prime number is like the only thing that goes into it is itself and 1. So 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, so forth. So 2 goes into 8 4 times. And I keep on going until I end up with a prime number. Okay, 4 is not prime, so divide it by a prime number. Well, 2 goes into 4 as well, and we get 2. I stop here because 2 is prime. So now I back up and I ask myself, did anything repeat twice? Well, it did right here. Okay. If something repeats twice, you can bring that number out in front of the radical once, and whatever does not repeat stays on the inside. So this 2 right here that did not repeat, it sort of remained. It's a remainder in a way. It stays on the inside of the radical. Let's do another one. The square root of 48. Well, 48 is not a perfect square. If I type it in the calculator, it's going to give me a decimal. So let's take 48 and start dividing it by prime numbers. 2 is prime, so that's 2 times 24. Well, 24 is not prime, so keep going. 2 goes into 24 12 times. 12 is not prime, keep going. 2 goes into 12 6 times. 6 is not prime. 2 goes into 6 3 times. So we got a prime number we can stop. So now I ask myself, did anything repeat twice? Well, this 2 repeated. This set of 2 repeated. So for each time that it repeats, bring it out once. 2. I can bring this set out once times 2. And this 3 here did not repeat. So I leave it on the inside. So that is 4 square roots of 3. Let's keep going. The square root of 150. Well, 150 is not a perfect square. If I type the square root of 150 in the calculator, I get a decimal. So I'm going to take the number 150 and start dividing it by prime numbers. We could say, we don't have to start with 2. We can start with 3. 3 is prime. 3 goes into 150 50 times. 3 doesn't go into 50. 50 is not prime. Let's see if another number goes into it. 2 does. 2 goes into 50 25 times. Well, 25 is not prime. I got to keep going. 5 goes into 25 5 times. So I look to see, I can stop because 5's prime, this 5 right here. So I look to see if anything repeats. And the 5 does. Excuse me, I'm sort of drawing crooked there. The 5's repeat. So they can come out one time. And the things that do not repeat twice, 3 and 2, have to go inside of the radical. So just to simplify that down, it's 5 square roots of 6. And one more example. The square root of 1350. If I type this in my calculator, I get a decimal. So I take 1350 and I start dividing it by prime numbers. Okay, well I know 2 goes into it because it's even. So 2 times 675. And 2 doesn't go into that, but 5 does. 5's prime. 5 does 135 times, and I know 5 goes into 135. It goes into there 27 times. 27's not prime. Keep going. 3 goes into 27 9 times, and 3 goes into 9 3 times. So I look to see what repeats. I have a 3 right here, so that can come out once. And I have a set of 5s, so that can come out once. And the 2 and the 3 do not repeat. So they stay on the inside. And my final answer is 15 square roots of 6.